Tom, so tell us about your invention.
It's a permanent magnet transformer. It works much the same as a regular transformer, except it uses a permanent magnet rather than a primary coil. Now, a primary coil, a normal transformer, you have a primary coil and a secondary coil. The primary coil, you use like an electric magnet. It creates a flux field that's passed through the transformer core. That flux field is picked up by the secondary coil and turned into electricity and then moved into whatever you want. You can jack the power, the voltage up, the ampage down, or the ampage up and the voltage down. That's a normal transformer. What mine does is I use a permanent magnet sliding in and out across a magnetic flux horizon that separates the two cores so that the flux field goes up or down depending on where it is between the twin cores. As far as the current goes, it's pretty much set with whatever coil size you want. If you want a high ampage, low voltage, then you would have heavier wires with fewer turns. If you want high voltage, low ampage, then you would go many more turns, smaller wire. It cannot be run as a motor. Most generators and alternators can be run as motors. This cannot. It's a very, very simple device, almost deceptively simple. The thing that makes it really neat is that I don't have to open and close the air gap on the magnet. Opening and closing the air gap is what generates heat. You generate enough heat into the magnet, you lose your field. For neodymium, it's about 320, somewhere in there.
Okay. For the average person, what would this device do for me?
Okay, the simplest way to put this is you can introduce approximately 100 watts into it and you get out 1,000 watts. It's a one-trick pony. You can't go too big, you can't go too small. It's sort of like Goldilocks, there's a just right spot. But you can hook them in tandem. So you can power much larger devices by just stacking them, much like you stack batteries now.
Okay, so how long would this last?
20 years or more. As long as you don't overload the magnets, you've got decent bearings, it'll go on and on and on and on.
So you're saying that this is pretty much an indefinite source of energy?
For the most part, yes. There probably are limitations. I do not know what they are at this time because we haven't reached them.
Okay, so you've heard about the other energy solutions. So what is the advantages of yours over the other ones?
It's very easy to construct. It's relatively inexpensive, and it's very, very simple. And it can be used in conjunction with just about any other alternative energy source. Solar, wind, hydro, a thermal engine like a Stirling engine. There's all kinds of ways you can utilize this.
Okay, well, now, this is kind of hard to believe. So, why hasn't anyone else discovered this?
Well, rare earth magnets really haven't come into prominence until the 1970s. So back in the days of Edison and Tesla, the magnets weren't that good. The first generating unit that Edison used, I think it was less than 200 watts of power, and it used a permanent magnet. It used a horseshoe magnet. Mm-hmm. And it was huge, comparatively speaking. The magnets just weren't that good. And by the time that rare earth magnets started to become abundant and cheap, everything was pretty much fixed around rotary, the rotary motion of an alternator or a generator. And there were some linear alternators, but they had a tendency to heat up. There was a lot of EMF resistance. They just weren't as effective as they could have been.
You were saying Tesla put out 200 watts, and how much would this put out?
On a 2-inch circular magnet, you can put out 1,000 watts.
Oh, and 1,000 watts?
1,000 watts translates out to about 1.5 horsepower.
Okay, and that can power what?
1,000 watts would power up a microwave oven, a refrigerator, a small air conditioner, do a real good job on a space heater. There's a number of things you can do with it. You only need about 4,000 watts to run your house, as long as you don't turn everything on at once.
What about electric cars?
The rule of thumb is it's 8 horsepower per 1,000 pounds of weight. And yes, it would be very effective for an electric car. It would work better because of the size limitations. It would work better in SUVs and trucks than it would in the little tiny roller skates.
So you're saying I could power my SUV?
Easily.
So this is revolutionary.
Absolutely.
Okay. Well, thanks, Tom. Thank you.